Hello, .NET Oxford. It's super exciting to be back. I did a lightning talk last year already, and now I'm happy to make a glorious return. Thank you very much for having me. Thank you very much for joining. I'm going to talk about not all of them because there is just too many for a 15 minutes time slot. Some of the new and improved APIs in .NET 6. My name is Stefan Pölz. I like clean C# code and test-driven .NET development, and let's get right started. So everything you see is also on GitHub. I will share the link afterwards. So let's start with one that I use all of the time, and I love it. So previously we had the argument null exception, and if we had a method, some public method, where we want to validate that the parameter that the user is passing in is not null, we can validate, and if it is null, we throw an argument null exception, which is better than later on, further down the call stack, than throwing some null reference exception. But with .NET 6, this is now a little bit simpler. So we could, everything is unit tested. We see on the side, everything is green. So we call the method with null, and then we assert that we indeed get the argument null exception. And with .NET 6, there is a new static method on argument null exception called throw if null. And we can pass in the parameter in here. I save, tests are re-executed again, and everything is still green. So it has the very same behavior. If you have a look inside, actually, this throw if null has an interesting thing. It uses the new caller argument expression. Actually, this attribute has been here for some time, but now C#10 is aware of it. And what it does, if we could pass in here any expression. Let's say I just pass in an expression. Let's do a ternary expression. If true, then parameter, otherwise null. And if I save and re-execute the test, we will see that the parameter name actually now includes this very expression. There it is, true, question mark, parameter, colon, null. It's exactly this expression. So this is the caller member expression that is working here. So we know exactly what has been null. On to the next one. Whenever we wanted to have a quick random number, we always needed to instantiate a new random instance or have it statically somewhere shared, then call random next so that we get a number. There is an interesting fact to know that random, this default random instance, is not thread safe. So theoretically, this could return 0, although it shouldn't. What was added is now we can say random.shared. So this is a special shared index. This is static. You can access this all over your application. And this one is thread safe. And this is how we can quickly get a random number. However, this should only be used for non-security critical code, of course. But let's come into a bigger change. So we had date time, I believe, is it there since .NET 1? Actually, not sure, but I believe so. And now with .NET 6, we have the date time split up into date only and time only. So those are as well structs. We can initialize a new date only, and it indeed consists only of a year, a month, and a day, without any time information. It's just some day. We have several properties. We have the year, we have the month, we have a day, we have a day of the week. Today is Tuesday. We have a day of the year. In our case, it's 31 from January plus 15. And we have a day number since the documentation says since January the 1st, year 1. So according to that, today is the 783,200th day. There is also a min value, a max value, very similar to the, date time. We can add years, add month, add days. We can convert the date into a date time by additionally adding a time only on top of it. Then we have a full date time. We can also go the other way. We can convert a date time into a date only, which basically then discards the time information. And we can also parse it, very similar like date time. And the same similar counterpart also exists, time only. So time only now consists of an hour, a minute, a second, and a millisecond part. And it's again very similar with a min value, a max value. Not sure. I didn't get this test warning doing something wrong here. We also have adding hours. There's also the plus minus operators. They're all overloaded. And similarly, we can convert from a date time to a date time. No, not to a date time, but actually to a time span. So time only can be converted to and from time span, and again, parsing. And another thing in the date time and time zone department is changes in the time zone info. So previously, before .NET 5, we needed to be careful to not mix up the time zone identifiers. So Windows and non-Windows systems use different databases. So Windows has the Windows style time zone identifier, and other systems such as Unix, they use the IANA database, which have this kind of syntax. And if we would try to use the IANA syntax on a Windows system or vice versa, this would crash. It would say a time zone not found. But now with .NET 6, we see I have here the is Windows check, and then try to find the time zone with the Windows identifier. Of course, this works. Now, if I false this, now the other code is executed, and the test, since we are on .NET 6, actually turns green, and I can use indeed the IANA identifier also on this Windows machine that I am on. Additionally, we can convert. So we can try to convert from the IANA identifier to the Windows identifier. So we can assert we now have the Windows identifier. This also goes the other way around, from a Windows identifier to the IANA identifier. We maybe need this if we need to communicate between systems which are not aware of both the identifiers. And additionally, the IANA system has something as a default region. For example, Europe London is for the for the Windows identifier, GMT standard time, the default equivalent would be Europe London. But if I also pass a region, PT, in that case Portugal, now I get the non-default region, which is in our case now Lisbon. So much for time zone info. Now a very highly used addition will be all the new link methods. So let's see what has been added in link quite a bit. We can now chunk. So here I have a range from 0 to inclusively 9. So this will be 1, 2, 3, 4 until the number of 9. We chunk it by a size of 3, which means we get chunks which have a maximum size of 3. So we can now assert that, so we get an enumerable of int arrays. And each int array is one of those chunks having each a maximum length of 3. We can assert that at index 0, we have 0, 1, 2. At index 1, 3, 4, 5. At index 2, 6, 7, 8. They're all 3-sized chunks. Now we don't have 3 numbers left, we only have 1 number left. So the last chunk actually now just contains 1 element. So this may be useful to split up work and, on parallel algorithms, for example. There was a distinct before, now we have a distinct by. I have here a struct, no, not a struct, a record class, which consists of a text and a number. I pass in 1, 2, 3, 4 as text, and twice the number 1, twice the number 2 as the number. And I can now select distinctly by the number. So I will get the first element with the number 1 and the first element with the number 2. We actually assert that. So, and this distinct by, so this by lambda that we can now pass in, this selector, also exists for except by, intersect by, and union by. Element add has been there before, but now also supports the index type. This has been added, I think, in that standard 2.1. And we can, with this annotation, with the head 1, we basically select the last element. And indeed, from this range from 0 to inclusively 9, we get the last element. Be careful, if I say head 0, this is basically the length of the collection. We will get a, there it is, argument out of range exception. There is also, for element at or default, also accepts now an index. First or default now also accepts custom default. Previously, it would have been the default from the type. So in our case, int would be 0. But I can now explicitly state a default, which should be selected if nothing is found. I have an empty enumerable, nothing is in it. There is no first element, so we get the default that we have specified here. Same exists for last or default and single or default. There we have max. So with max, we can pass in a comparer, then it selects the maximum element, also for min. Likewise, there is a max by, where we can, similar to the distinct by, pass in a selector, which then gets the maximum element. In our case, that's the this one. Or same for min by. We can take elements now with the new range of, type, which has also been added in NetStandard 2.1. In this case, I say, give me from index 1 to index 8 in that case, so length minus 1, which is the elements from 1 through 8. So we cut off 1, 0, and 9. Then there is a method try get non-enumerated count. This is similar to count, but it only returns the count if no enumeration is forced. For example, I make a range here, then I do a take, but this now returns just an iterator, which has not been enumerated yet. Only if I for each it, then it will be enumerated. And this try get non-enumerated count actually returns false, and the count is default because it has not been enumerated. However, if I would pass in here like an array, 1, 2, 3, an array has a length, so it doesn't need to be enumerated. We can access the length property, already completed length property. So the test fails because now it is successful, should be true. And the count indeed should be 3. Test will turn green in just a second. There we go. And zip, there was a zip before. Now there's a zip which also takes a third element. And not sure if all of them, but most of those methods are also available at Queryable. Speaking of collections, there's also now a new priority queue, which is basically a queue, but with an added priority. We can define a custom comparer. We can ensure the capacity, like with many collections. We can also trim excessive items if we want to. And if we enqueue elements with the same priority, they get first in, first out, first the 1, then the 2. However, if I use a different priority, now I enqueue the 1 with priority 2 and the 2 with priority 1. So now priority 1 has a higher precedence. So although it has been added second, it will be dequeued first, and then the one with the lower priority. There's also an optimization. If you want to enqueue and dequeue all in one, we can use enqueue dequeue, which is a more efficient step. Then there are some task helpers. Now we go a bit into the async world. Oops. So with task, there has been added a wait async method. This basically gives us a new task which cancels after either a timeout, in this case I do 10 milliseconds, or also supports custom cancellation. However, what is very important to note here that the original task that we await actually is not canceled. In .NET, async methods need to have cooperative cancellation. If the original task does not support cancellation, it cannot be canceled. So the original task lives on. Here in this test, I have the evidence that this original task is still not completed, although the new task that you receive with wait async is actually completed. So this is how we could still have cancellation or either cancellation or timeout on an API which doesn't support cancellation or timeout, but be aware that the original task is not magically canceled. Then we have, there was a parallel for each before, now we have a parallel for each async, which is basically very same than parallel for each. It also has parallel options, but the difference is that it allows a value task as the body, so we can have an async, a naturally async operation here to split up work. And there is a new timer in town, the periodic timer. This is a rather simple timer. We can create a new periodic timer where we pass in the interval or the period in which it should be launched. And then for each iteration, we can say, wait for next async. We could, for example, do this in a loop. A simple loop, for example, could look like while timer dot wait for next tick async. We await that. And now every 64 milliseconds, we will enter this body. And coming close to the end, there is two more things I want to briefly show. There is with .NET Core 3, .NET Standard 2.1, nullability, the nullable reference types have been added. And those nullable reference types, they add attributes on top of the code you write. And in order to, at runtime, analyze what those annotations mean, for example, Entity Framework is using that and generates then database statements allowing null or disallowing null also in the database. This could be used. So what we need as an entry point, so basically I have here I have two properties. I have a property which is not nullable, but it allows null, which means we can actually set null, but get is non-null. And in the other way around, we have a disallow null property, where the string is nullable, but we disallow null. So if we get it, the string we get could be null, but we can never set null. This would throw here. And if we would do this per default and analyze all those attributes which get added, this would be quite tough and very error prone. But with the new nullability info context, it's very simple. So we spawn a new nullability info context, which we can keep around as long as we want to keep this information cached. Then we create from this context with the property that we get via reflection, a new nullability info. Then we can ask questions about this nullability info. So what's the type? It's a string. What's the read state? It's not null. So this is the read state of our allow null property is the get. It is not nullable. However, the set null is allowed because of that attribute. And this is why the write state here is actually nullable. We also have an element type if this would be an array, and we have generic type arguments if this would be, for example, a generic method. And the very last thing I want to show is source generators. So there has been several source generators be added. One of them is used by system text JSON. So we can automatically generate very efficient code. Basically what I have here, I define my entity, and all I do is a partial class, which derives from JSON serializer context. I pack in those attributes on top. And now if I actually F12, we get this type is generated, the default property. We never wrote this default property. This is generated. If I F12 this, I will jump to some generated code. We see this is auto-generated at the top, .g.cs. This is generated by a source generator. And there's a lot of code, and it's now very efficiently passed, both serialized and deserialized way to JSONify and deserialize the types. And I know this was a very quick view about everything. I am aware that not everything sticks in your head immediately, but I just wanted to give you a brief of an overview of what is there, and maybe next time you remember, ooh, there was something, wasn't it? And maybe this could be very useful to you in the future. If you want to learn more about all those diffs, all those things, all those links are available. So we can go, basically there is a page, you can go to the .NET Core repo, go to the API diff, And this is basically all the diffs, what has been added. I just select what did we have a look on. We looked at the reflection, and there we see here were those types added that we had a look at. Also, there is the page apireview.net. The .NET team every Tuesday, I think they are about it right now. They on YouTube, they are reviewing API requests, and which will be then going to be implemented in .NET 7 and later. If you have any questions, then you could reach me at Twitter. I am 0x_f0. I will put in the chat the link to the slides. I also recently started streaming on Twitch. My next session is actually on Saturday. If you want to have a look at flashover.net, this is a very highly under construction site where I post my schedule, and we'll be doing next definitely something with Forslin. Source generators is on the plate. And yeah, thank you very much for staying a while and listening. And now I can't announce the next speaker, but what I can announce is the break. So I guess it's time to get a drink. See you later.